Today we're going to be doing another Amazon's interview question. And this is question number 29, divide two integers. This is also one of Facebook's favorite interview questions. Uh, we are going to be dividing two integers, or the one which in division, then the integer which comes on top of division is called dividend, and the integer which goes under the dividend is known as divisor. There are other restrictions over here. We'll program as required. Basically, they are saying that if you see if the quotient is strictly greater than this number, just return that, and if it is strictly less than that, return negative of minus 231, 2 raised by 31. The algorithm is like that we need to reconsider how we divide numbers. So let's say if we are dividing 10 divided by 3, like normally if you want to think of it as like you're gonna be adding 3 again and again until it is less than 3, and then like what I'm saying is like maybe you're gonna be thinking that you have 3, you're gonna be making it 6, then 9, and then 9, and then because you did it 3 times, so there will be 3, and then uh, there will be 3 times you kept adding 3 to it until you reach there, and that would be the answer over there. So if we do it similarly for 16 divided by 4, you will do is like you will take the divisor 4, kept adding 4 in it, so that will make first 4, then 8, then 12, then 16, and then you will know that the answer and 16 is going to be less than that, so that would be 4 would be the answer, and you can get 216 and 4 like after doing it 4 times, so the 4 is going to be the answer. This is a trivial solution. This is not very efficient. Uh, that's not clear. That won't clear the interview, and you won't like so. This time complexity is because every single time you are actually uh, doubling it. Not even doubling it. You are actually adding divisor into the divisor. So it's going to be 4 into whatever we have, 4, and then it's going to make it 8, and then we'll be adding divisor again, which is 4 into 8, and then that will make it 12, and then again we're doing it. So we are going linearly, right? And then that would be, so that would make it linear, and we want better than that. Okay, so in order to come up to an algorithm, we need to rethink about division here. It is not intuitive. The algorithm is not intuitive at all. We don't divide numbers like that. So the algorithm is like that. If you are dividing, let's start with 10 divided by 3. The algorithm is like this. Think of it as I'm gonna double 3 every single time, right? Sorry, I'm gonna multiply 3 by 2 every single time. I'm not adding 3 with 3. I'm not doubling it, whatever doubling means right now. But what I'm doing is like I am multiplying whatever divisor is. So in this example, let's say the A, which is gonna be the dividend, is gonna be 10, and B, which is gonna be the divisor, right? So every single time, if you multiply this b, which is the divisor, by 2 until the answer becomes more than a, which is 10. So this is going to become 3 multiplied by 2 is 6, multiplied by 2 is 12, multiplied by 2 is 24. So you are taking that result or the b and you are multiplying by 2 every single time. 3 is going to become 6, 6 is going to become 12, 12 is going to become 24. And you're going to stop where the answer becomes greater than a. So in this case, we're going to stop right here because the next time the answer actually did become more than, the next one was 12, so it did become more than a. So what happened is, like, we did it twice. Uh, we actually multiplied, sorry, so we actually multiplied 3 with 2 times. So this is a factor, x is a factor, and we did it 2 times. Let's do it one more time. We did it one time. X is going to be 1 because we are not going to consider when the b is going to exceed a. So our x is only 1 and this is a factor. Our result is gonna take this shape, result plus equals to 2 raised power this factor. So result is initiated as 0. So we had this factor as 1, that okay, whatever the divisor we had, we actually multiplied it one time in order to, unless it stayed like until it uh, remained lower than a, the dividend. So we just had to do it. The factor is gonna become this. So 2 raised power that 1 is gonna make it equal to 2. And then we're gonna bring our a, like what we're gonna be doing is, like, we're gonna say that okay, a is gonna be negative equal to this thing, which is 6, and this is gonna make it 4. Then we're gonna start again. A is equal to 4, b is equal to, again start with 3. B's value never changes, right? Only a and the result values are keep changing. So again we're gonna do the same thing. What would be the factor? And the factor means that how many times you can multiply b by 2 that it stays less than a, and that would be 0. And again the result, as I said, is gonna be equal to 2 raised power x. This time it's gonna be 2 was the previous value, and this is gonna be 1, so that would be the answer here. And the next time the a is gonna get updated to, again, 4 minus 3, that will make it 1. So we won't get into this one again, as a is 1 now and b is again 3. So we're gonna stop doing this calculation when the a would become less than b. Again, it's not intuitive, but there is a way we can divide two numbers, and that's gonna give you logarithmic complexity, and that's what they are looking for. Let's take another example of a equals to 16 and b equals to, let's just say, 4, right? In this case, the first thing is we're gonna keep multiplying b by 2. So we're not making it equal, just to show you what we are comparing a with. It's basically multiply equals to 2. So that would make it 8, 16, 32. Over here we cannot do that because this has exceeded a, so we'll stop right here. And how many times we multiplied b by 2, that would be the factor. That would be 1, 2, right? And then our result is basically plus equals to, it starts with 0 but it becomes 2 raised power that factor. That would make it 2 raised power 2 is equal to 4. That is 4. Now the next thing is that the a is going to become equal to a is going to become equal to uh, like 16 minus 2 factor of that one, so that is going to make it 0. So now the a and b stays the same as 4. We won't process it again because a is less than b now. The more you would do it, the more better it would become. The reason we are doing it is because multiplying a number by 2 is very easy. We actually left shift the number by 1, and that would be it. I really wanted to do one more time just to be clear. Let's take an example of a equals to 10 and b equals to 2. Again, the result starts with 0, right? The b is actually, let's do it, let's look at the logic and then we'll come back to this one, that what exactly is going on. So over here we have this condition. We are basically programming this thing, this condition here, that if this is, so 1 left shifted 31 times is going to overflow. If it is overflowing, right, and the b is equal to -1, just return whatever he said, 2 raised power 32 minus 1. So we are doing that. This is going to make it 2 raised power 31 2 raised power 31 minus 1, as we have been told what to program over there. So basically the algorithm starts from here, right? So we are gonna remove any negatives, and at the end, depending on which value is negative, if both of them are negative, we're gonna return a positive result. If one of them, only one of them is negative, we're gonna return a negative result. Other than that, all calculations are going to be done making them just taking the absolute values. So while the a is uh, greater than equal to 0, as long as a is basically uh, bigger than or equal to b, we're going to process that. Okay, and what this is doing, this line is basically calculating that factor x. The x factor, this is the x factor, like how many times you actually multiply b with 2, right, until the answer becomes greater than a. We're not changing the values of a or b here. All this line is doing is basically taking the b, let's say in this example it's 2, left shift x, which starts with 0. So we are not doing anything in here, we're just gonna be b, which is 2, again left shift one time, right? And then what would be the answer? 2 left shift, getting left shifted one time is gonna be 2. So 10 minus 2 is still greater than equal to 0, so we're gonna keep incrementing. So x is gonna become equal to 1. This is gonna become equal to 4, right? And then again we're gonna keep doing that. This is gonna become 4 because we are left shifting it. X is now 1. We're gonna try to left shift it 2 times. So 2, and then that is multiplied by 4. Again left shift one more time, that is gonna make it 8, and this is gonna become 2. 2. We want to try to do it one more time, but we are actually left shifting it basically 3 times, right? Oh, sorry, we are left shifting it 2 times and then 1 time. of that. So basically, if you take 2, left shift it 2 times, that is going to make it 8. Left shift it one more time, that is going to make it 16. That is going to be bigger than that. We're going to stop incrementing x, so x will just stay. No, because we, how many times we multiply 1? Okay, 1 and then 2, so that would be 2. Yes. Yes, so that will, we won't increment the x again, right? And then that will will stay at x equals to 2 because we just multiplied it 2 times. Okay, and then once we have x equals to 2, the result is going to become equal to 2 raised power 2 is 4. We're going to keep that, and then we want to reduce our a. This is going to become this 8 is going to get subtracted from 2, left shifted 2 times, which would make it 8. So that will, the result will be just 2. We're going to enter again with a equals to 2 and b equals to 2. Result this time will start with 4 and x will start with 0. Again, this one, when we'll come here, we will get into it, and because a minus, we'll get into this while loop because a minus b is still greater than equal to 0. It's equal to 0, and now this will basically not increment because you cannot, even if you actually multiply this b with 2, it's gonna become greater than a, the condition won't stay. So every single time we are actually making x again equals to 0, and again the result is gonna be this 4 plus 2 raised power 0, which is gonna be 1. So the answer is gonna be equal to 5. After that, the a is gonna get updated to equal to 0. From here, we won't enter in this while loop again, and we're gonna be returning 5. That's all. In terms of the log, the complexity. In terms of the complexity, we are actually incrementing the divide and incrementing the divisor. We are we are reducing this down and incrementing this one. So logarithmically we are reducing it down, and logarithmically we are increasing it. So the time complexity is actually log of n square, n being the n being the value of the dividend. Yeah, so n being the value of the dividend, it's actually log of n square would be the time complexity, and we are not taking any extra space. That's all I wanted to cover. Thanks for watching.